Now let us see the method to find complementary function. First step, we should write the auxiliary equation f of d equal to 0. Solving this equation, we get values of d, say m1, m2, etc. mn. So these values of d may be real and distinct, or it may be real and same, or it may be complex numbers. Now, the first case, we assume the values of d are real and different. Different means distinct. That is, m1 is not equal to m2, is not equal to m3, etc., not equal to mn. All these m1, m2, etc., mn are real numbers, but they are not same, different numbers. In this case, the complementary function rule is, write Cf is equal to C1 into e to the power m1x plus C2 into e to the power m2x plus plus Cn into e to the power mnx, where C1, C2, etc., Cn are arbitrary constants. Next, case 2. Here, first subdivision, let m1 equal to m2 and m3 is not equal to m4, not equal to, etc., not equal to mn. This means that m1, m2, two roots are real and same. M1 and m2 are real and equal, and the remaining roots are real and different. That is, m3 value is not equal to m4 value, m4 value is not equal to m5 value, etc., not equal to mn value. So first two roots are real and same. Remaining roots are real numbers, but they are different. In this case, CF rule is, complementary function rule is, write CF is equal to, inside the bracket, C1 plus C2x, outside the bracket e to the power m1x, plus C3 e to the power m3x, plus Cn e to the power mnx. Next subdivision, now we assume let m1 equal to m2 equal to m3 and m4 is not equal to m5, m5 is not equal to m6, not equal to mn. This means three roots are real numbers and same, but the remaining roots are real numbers and they are not same. They are different numbers. Is it clear? M1, M2, M3, three values of D are real numbers and they are one and the same. Remaining values of D, say M4, M5, etc., Mn are real numbers, but they are not same numbers. They are different numbers. In this case, the complementary function rule is, write Cf equal to, inside the bracket, C1 plus C2x plus C3x square, outside the bracket e to the power m1x, plus C4 e to the power m4x plus C5 e to the power m5x plus plus Cn e to the power mnx. Here also C1, C2, etc., Cn are arbitrary constants. So like this rule can be extended. So, say for example, assume four roots are real and same, real and equal. That means m1, m2, m3, m4, all these are real numbers, they are same. Remaining m5, m6, etc., mn are also real numbers, but they are not same. They are different real numbers. So in this case, the complementary function rule is write CF is equal to inside the bracket C1 plus C2x plus C3x square plus C4 x cube outside the bracket e to the power m1x plus C5 e to the power m5x plus C6 e to the power m6x plus dot 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 plus Cn e to the power mnx, where all these C1, C2, etc. Cn are arbitrary constants. I hope all are understanding in this case. Next, case 3. First subdivision, let m1 equal to alpha plus I beta, m2 is equal to alpha minus I beta, and m3 is not equal to m4, not equal to m5, not equal to etc., not equal to mn. This means that the values of two values of d are complex numbers. Okay, say m1, m2 are alpha plus I beta and alpha minus I beta. Because there is a theorem, complex roots occurs in pairs. Therefore, alpha plus I beta is a root means alpha minus I beta is also a root. That is why here I written m1 equal to alpha plus I beta, m2 is equal to alpha minus I beta. The remaining values of d, they are m3, m4, etc., mn. All these are real numbers, but they are distinct numbers, different numbers. Okay. So in this case, the complementary function rule is write CF is equal to inside the bracket C1 cos beta x plus C2 sin beta x outside the bracket e to the power ax plus C3 e to the power m3x plus C4 e to the power m4x dot plus Cn e to the power mnx. Next subdivision, suppose m1 and m2 complex numbers, but they are equal. That is, m1 equal to m2 is equal to alpha plus I beta. Then the next two roots, say m3 and m4, they are also equal, but that must be the conjugate of alpha plus I beta. So m3 equal to m4 must be alpha minus I beta, and the remaining m5, m6, etc., mn are real numbers, but they are distinct, different numbers. I repeat, now m1, m2, two roots are equal as alpha plus I beta. Third and fourth roots also equal, they are alpha minus I beta. So totally four roots which are complex numbers. Remaining roots in other words the values of d. What are they? m5, m6, etc., mn. They are real numbers, but they are different numbers. So in this case, the complementary function rule is write CF is equal to inside the square bracket you have to write two terms. In the first term, put your small bracket. Inside the bracket, write C1 plus C2x. Outside the bracket, cos beta x. In the second term, inside the small bracket, write C3 plus C4x. Outside the bracket, sin beta x. Then outside the square bracket, write e to the power alpha x plus C5 e to the power m5x plus C6 e to the power m6x plus dot 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 plus Cn. So where all these C's, what are they? C1, C2, C3, etc. Cn are arbitrary constants. So like this rule can be extended. Let us do few problems in homogeneous linear differential equations. First question, solve d square minus 5d plus 4 inside the bracket, outside the bracket y equal to 0. See here the maximum power of d is 2. Therefore, what we are given is second order differential equation. Next, coefficient of y is 4, coefficient of dy is minus 5, coefficient of d square y is 1. Okay, the coefficients of y, dy, d square y, all these are constants. That's why this equation is said to be linear differential equation with constant coefficients. Constant coefficients. Is it clear? So what we are given is a second order homogeneous linear differential equation with constant coefficients. We say this is a homogeneous equation because right hand side is 0. In other words, this equation is having only y term, dy term, d square y term. Okay, so what we are given is a second order linear differential equation with constant coefficients. The general solution or the complete solution to this equation is y equal to complementary function. So here solve the equation means that find out the general solution to this equation. So meaning is same. Solving the equation is same as finding the general solution. Other name is complete solution. So first step, write an auxiliary equation, that is leave the y, write the remaining. It is d square minus 5d plus 4 equal to 0. This is an quadratic equation involving the variable d. You know very well how to solve this equation. Solve the equation means find out the roots of the equation. In other words, find out the values of d. So there are many methods are there. First method, the general method to find the roots of the equation. Roots of the equation, in other words, values of the d. Okay, the well-known quadratic equation is ax square plus bx plus c is equal to 0, where a, b, c are given constants, x is the variable. This is a general quadratic equation. It has two roots, in other words, two values for x. So we have formula x is equal to minus b plus or minus square root of b square minus 4ac whole divided by 2a. So you can adopt this method. Okay, so compare the given equation with the general quadratic equation, then adopt this formula so that I am getting d is equal to 5 plus or minus root 25 minus 16 whole divided by 2. This is 5, 3 plus or minus 3 by 2. So rewriting into two values of d, they are d is equal to 4 and 1. Both are real numbers, they are different numbers. So complementary function is c1 into e to the power 4x plus c2 into e to the power 1x, where c1, c2 are arbitrary constants. Then finish the problem by writing the general solution, that is y is equal to CF. CF we already arrived, substitute. CF is equal to C1 e to the power 4x plus C2 into e to the power 1x. So in this problem, I adopted the general method to find out the values of D. This method is applicable to all the problems. So it is better you adopt this method. Okay. Another method is known as factorization method. This method is applicable to only few problems but not all the problems. So the factorization method is the middle term, that is 5d, must be written as two terms satisfying the two conditions. First condition, the sum of those two is equal to the middle term. Product of those two is equal to product of the extremes. Here what are the extremes? D plus d square and plus 4. So using this rule, you must rewrite the middle term minus 5d into two terms. How to write minus 4d minus d, that is equal to minus 5d. See here, the sum minus 4d minus d is equal to the middle term of the equation minus 5d. The product minus 4d and minus d is equal to plus 4d square, that is same as in the given equation, the product of the first and the last term in the left hand side. So this is the correct way of factorizing the middle term, rewriting the middle term. Then seeing the first two terms, take the common factor out. So here the common factor is d. Then comparing with the first two terms, inside the bracket you can write two terms, they are d and minus 4. Then write this d minus 4 again and compare with the remaining two terms in the previous step, so that easily you can identify minus 1 is the common factor. Okay. Next step, take d minus 4 is common, then in the first term d is there, second term minus 1 is there. So now we have product of 2 is equal to 0. What are they? D minus 4 and d minus 1. Now equating each factor is equal to 0, that is d minus 4 is equal to 0 or d minus 1 is equal to 0. Now these two equations gives two values for d, they are 4 and 1, real and distinct. So you can adopt this factorization method. I remind you, this factorization method is not applicable to all the problems, whereas the general method to find the values of d is applicable to all the problems. And then suppose the middle term, say in this problem minus 5d, middle term is not there, there is a simple method is there, this general method, factorization method not necessary. If the middle term is not there in the quadratic equation, then take the constant term to the other side of the equation, then take square root, immediately you will get two values for d with a plus and minus sign. Is it clear? If all the terms are d square term, d term, constant term are there, you go for the general method. Okay, this is applicable to all the problems. In few problems, the factorization method is applicable. Suppose the middle term is not there in the quadratic equation, take the constant term to the other side, take square root on both sides, then with respect to plus sign and minus sign, you will get two values for d. I think all are following. Question number 5. Solve inside the bracket d cube minus 3d square plus 4 outside the bracket y is equal to 0. So here what we are given is a third order homogeneous linear differential equation with constant coefficients. Write the auxiliary equation as d cube minus 3d square plus 4 is equal to 0. See, suppose this is a quadratic equation means you know how to find out the values of d by the general method or factorization method or other method. In case of a third degree equation, okay, first by inspection method you should find out one value for d. What's that inspection method? Put a suitable value for d. See whether that value satisfies the equation. If it satisfies, then that value must be a root. So this is known as inspection method to find out one value of d. Preferably, you substitute d is equal to plus 1, minus 1, plus 2, minus 2, plus 3, minus 3. Enough. So in this problem, I verified by putting d is equal to 2, the equation is satisfied. Therefore, we write by inspection method d is equal to 2 is a root. What we have is a third degree equation. It has three values for d. One value for d we arrived. To find the remaining two values, we adopt a synthetic division method. In this method, first row, write the coefficients in order. That means first coefficient of d cube, next coefficient of d square, next coefficient of d, and then constant term. In the equation we don't have d term, therefore coefficient must be 0. Okay, I repeat, write the coefficients in order. First coefficient of d cube 1, next coefficient of d square minus 3, and coefficient of d is 0 because here there is no d term. Finally, write the constant term. Okay. Then put a line like L. Left hand side of that line, write the value which you already arrived by inspection method. That is 2 in this problem. Then in the second row, first number always 0. All the problems in the second row, first number must be 0. Now you add vertically. That means 1 plus 0 is equal to 1. Then multiply this 2 into 1 and write this number in the second place. Then second vertical line you add, it is minus 3 plus 2 means minus 1. Multiply 2 and minus 1 and write in the third place. Then add vertically 0 and minus 2 gives minus 2. Then multiply this minus 2 with the root we already arrived 2. 2 into minus 2 is minus 4. Write that minus 4 in the fourth place. Then add vertically, you must get 0 to all the problems. Remember, the last entry must be 0 in all the problems. Then what we are given is a third degree equation. Now you write the equation whose degree is 1 shorter than the original. Original is third degree equation. 1 short means a second degree equation. In the second degree equation, okay, coefficient of d square is, see the previous step, coefficient of d square is the first number 1. Next coefficient of d is the second number minus 1. Third is minus to the constant term equal to 0. So write the corresponding second degree equation in D. So this is quadratic equation. You know how to solve the equation, how to find out the values of D. So I am going for the general method. D is equal to 1 plus or minus square root of 1 plus 8 whole divided by 2. So with respect to the plus and the minus sign, D values are 2 and minus 1. Now we arrived all the three values of D. Now, all the three roots. What are they? 2, 2, minus 1. Okay, 2, 2 and minus 1 are the roots of the auxiliary equation. Now complementary function CF is equal to, see here 2 is repeated, real and real number and same. So because of this reason, we write the CF is equal to inside the bracket C1 plus C2x, outside the bracket e to the power 2x. Then with respect to the another value for D, that is minus 1, write C3 e to the power minus 1x. So I repeat, here two roots are real and same. Next one is different. Since two roots are real and same, you should write CF is equal to inside the bracket C1 plus C2x, outside the bracket e to the power 2x, plus C3 into e to the power 1x. Then the last step, general solution, is y is equal to CF. So write the CF is equal to C1 plus C2x inside the bracket into e to the power 2x plus C3 into e to the power minus x.